here is the plan for the next 2 weeks, because we've got 2 weeks left. And
Only 2 weeks left?
yes, our last day is the 15th, and then we've got finals. So
Are we for sure having exams?
Huh?
Are we for sure like having exams?
yeah, Mr. Swap
Sure.
down an email yesterday to
Oh.
parents
Let
about
me just smash this on your head for a minute. Yeah.
Okay, you scare me with that.
Yeah, for real.
I'm professional.
So we
Okay,
will go through May 15th. He said we will have a modified version of exams for 7th through 12th grade during May 18th.
Just a 5-question questionnaire.
Zach,
Yeah.
I do not
One,
appreciate
how
that
did you like
attitude.
class?
Oh,
2, how'd you like your classmates? 3, how'd you like the teacher? 4, did you learn? 5, I have this really long problem for you to do for number 5. So you can either get 100% or you can get 80% on it. A 5-question test, 20 points apiece. That's what I'll do.
Okay.
I can really imagine Samuel doing that though.
Well, he'll have a Jeopardy game in there too. Okay. So, yes. Here's
yes, I may have burnt the one side of pancake. See it?
so I can talk.
See my pancake?
All right. He's muted now, so you can't hear him. 12.1. We are just going to be doing the first 2 lessons in chapter 12, and then we will move to chapter 13. Because yes, we will just be doing the first 2 lessons. Then we'll jump to chapter 13 to end the year off of, and that will be as far as we get is chapter 13. So let's go ahead and I will pull up chapter 12. Here we go. We are dealing with transformations. These are in your book, so you don't have to write notes. So just follow along. Here we go. Well, what is a transformation? By definition, changing from one place to another place, changing in appearance. So we have different types of transformations we're going to talk about rotation, reflection, all those types of things. So that's what transformation is. It is, so the original image that we'll have is called the pre-image. And then the image that is made is called the image. So, for example, if you go and stand in front of a mirror, you, as the real thing, you would be known as the pre-image. The image that you see in the mirror would be called your image, which hopefully makes sense because you're not actually in the mirror. That's just your image in there. That would be called a transformation. A mirror would do a transformation of you. All right, so transformation, a one-to-one function from the plane to plane. Here we go. If I have these 2 triangles right here, is there any way to like block out his image too?
I couldn't find the shirt. Found it though. Don't worry. I'm getting there.
Okay. So here we go. This is a specific type of transformation that would be called a reflection. Here we go. So notice my original pre-image. This is my pre-image. And then this is the image that it makes. So notice my first point X would be reflected right here. The image, how do we notate the image? We're going to use this little piece up here. We say that's X prime. So my original pre-image of X, this is a 1-to-1 function. So x would be reflected on the opposite side. We'll talk about this middle line right here in just a minute. So y would be reflected as y prime, and z would be reflected as z prime. Notice, if I were to name this triangle my pre-image, that would be triangle XYZ, correct? Oops, that's a Z. Triangle XYZ. Now, my image is also triangle XYZ, correct? Because X and X relate, Y and Y prime relate, Z and Z, they correlate, excuse me, not relate. They're correlating sides, correlating points. But notice, which direction did I go here? Which direction am I going if I go from X to Y to Z?
Left.
Counterclockwise.
I'm going counterclockwise. In my image, though, I go from X, Y, Z. Which way am I going?
Clockwise.
So the transformation of a reflection is going to swap. Your ordering is going to be the same for whatever types of shapes that you're reflecting. When you name it's going to be the same, but the direction is going to change. It's going to go from clockwise to counterclockwise, vice versa, and that's just called the orientation, where the vertices, how you order those. So orientation. All right. Let's talk about, we've already started talking about reflection. A reflection in a line is a transformation. One side, and it's almost like it flips to the other side. So the pictures that we've seen already on the slide, the one in the previous one, this is a reflection right here. From one side, flipping to the other side. So here's the actual definition of reflection. It goes from point A to A prime. These conditions must be met. So 1, if the point lies on the line, then they're going to be equal to one another. The reflection points, the two vertices, A and A prime, they are going to be the same exact. But I believe for the most part, we're going to be dealing with reflections that look like number 2 here. If the point is not lying right on the line, then it's going to be a perpendicular bisector of A and A prime. Okay, we're going to go through this. First off, what is this line right here? Well, if you go back to the example of a mirror, if you're standing in front of a mirror, you're the pre-image. What you see in the mirror is the image. So the mirror would actually be, the line, the reflection in a line. So the mirror would be represented as this line L or whatever, wherever that break is, where the reflection is happening. Let me try to think. Another example would be, well, here's an example right here. Line K. This is the line of the break. So we are trying to reflect this triangle over here. Now we have a good idea of what it's going to look like. It's going to look like something like this, right? But let's go back to the definition of what we were just studying. So notice here, what is the comparison? Where is this triangle? Are any of the points on the actual line?
No, ma'am.
No. So are we going to
No.
Are we going to be talking about the first condition? If that point is lying straight on the line, then it's going to be equals. So we're going to be looking at number 2 here. If A is not on that line, then it's going to be the perpendicular bisector. So if I reflect this triangle on the other side of line K, I need to make a perpendicular bisector with point M to M prime. I need to make a perpendicular bisector with L and L prime. So here's what I know. When I make those perpendicular bisectors, it's going to give me 2 congruent halves. So this line right here and this piece right here, those are the same exact lines. They're 2 equal because I've made a perpendicular bisector right here. I've made a right angle and it has bisected the segment M prime. So it's a perpendicular bisector of this segment right there. Same right here with L and L prime. This point right here is the perpendicular bisector of segment LL prime. This line right here, this point right here, bisects segment N prime. Any questions so far? So how do you get a perfect reflection of one image on the other side of another line? Draw perpendicular bisectors. Now, technically, we've learned how to draw a perpendicular bisector, but with our compasses, for right now, I'm not going to require that you use a compass to draw a perpendicular bisector with all these. So when we do the exercises on the next page, you can take a ruler out. You'll need a straight edge though. You'll need to use a straight edge, but if you can do a really good job of guessing where that perpendicular bisector is, I will be fine with that. If you'd rather use the compass, by all means, go for it. That make that a good deal? Okay. Sorry, trying to let Abby in. Here she comes. Okay, so that's it for lesson 1. Hey Abby, I'm recording this right now, so you can go back and rewatch the lesson later after I get it updated. So let's take a look at number 1 on page 502. All right, because you're not going to be able to do these in the book, do the best that you can to locate the points. So what you'll have to do is you'll just have to draw the pictures that are in the book on your piece of paper, okay? So draw line L, and then we've got points A, B, D, E, and E. All right. So the directions say copy each figure below onto your paper and then reflect the pre-image across the given line. So this is the pre-image and we want to reflect that. So we'll have the image over here. So I should have 5 more points on the right side of this line. Okay, how do I do reflection? Well, I'm going to draw perpendicular bisectors to, where am I going to draw it perpendicular to? I'm going to draw it perpendicular to the middle line here, line L. So from A, I would measure out, let's see, I would draw a line there, and then let's see if I can copy that. Same line. Nope. Okay. So what you can do is you can just take a ruler for right now, for our purposes, measure this distance right here, and then you're going to reflect it across. So I've made a perpendicular line with L, and these 2 segments should be congruent. This is now A prime, not A, it's A prime, because when you reflect it, the new image is going to be A prime. And that's what you would do with all 5 of these right here. Drawing perpendicular bisectors to line L. All right. This would be E prime, and then and so on and so forth. These 2 segments should be congruent to one another. All right. Feel free, once you've drawn your perpendicular bisector, you're welcome to erase those lines there. If you keep the line segments there, that's fine as well too. So I have now made segment AA prime. I've made segment EE prime. That's how I would name these segments. All right. Number 4. How would you do it for number 4 then?
Copy and paste.
So here's number 4. Well, an angle is made up of 3 points, correct? So
Yes, ma'am.
draw a perpendicular bisector from the vertex to the line. Draw another one there.
Amen.
So there is
Should we label
right
the
here,
point?
line,
Or
and then draw a perpendicular bisector from this point here to the line. Draw another one from this point to the line. Here's my other points on my angle, and then draw a perpendicular line from that point there, that point there. So I have 3 points now on my angle. I can connect them using straight lines. So again, if the lines, if you don't have perfect perpendicular bisectors, then your angles aren't going to be the exact measurement. So make sure when you do get these perpendicular bisectors, these segments are congruent to one another. All right. Let's see here. I want you to do numbers 1 through 12 all.
Okay, that is A-okay.
Again, good. All right, page 502 to 503, numbers 1 through 12 all. Just started a couple of them for you. All right.